Hello students, I welcome you all to my channel Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now let's solve this problem. And this problem says that the motion of a jet plane just after landing on a runway is described by this T graph. And it is said that determine the time T dash when the jet plane stops. So we have to find this T dash where the plane will stop. And it said that construct the VT and ST graphs for the motion. Here S equals to 0, V equals to 300 feet per second when T equals to 0. Now the motion of the jet plane occurs in three different conditions and in three different time intervals. So we will consider each interval one by one. So the initial interval is from 0 to 10 seconds, right? So when T is greater than equal to 0 and less than equal to 10 seconds, we are given from this AT graph that the acceleration is equal to 0. So we can write that the acceleration is equal to 0. And the initial conditions are that S is equal to 0 and velocity is equal to 300 feet per second when T equals to 0. So this is the initial conditions. Now the acceleration is equal to 0, and from this we can say that dv by dt is equal to 0 since acceleration is equal to dv by dt. And from this we can write that dv is equal to 0 dt, and to find the velocity function we have to integrate this. So if I integrate this, so we have to integrate this from 0 to t, and this will be from initial velocity. So when t equals to 0, the velocity is 300. So this is 300 to v. So now if we integrate this, this will cancel out and we will be left with v, and that is 300 to v, and this side will become 0 since this is 0 into dt, so this will become 0. So now if we put the limits, we will have the equation v minus 300 equals to 0, and from this we can say that v is equal to 300 feet per second. So for this interval the velocity remains constant since the acceleration is 0. So this is 300. So let's say that this one box represents 50. So 50, 100, 150, and this is 200, 250, 300 somewhere here. Let's say this point is 300. Let's say this is 300 feet, and this is 10 seconds, let's say. So the velocity remains constant for these 10 seconds, and that is 300. Now we have to find the S of t graph. We have to plot the S of t graph. So for that we need to have the S of t equation. So now as we know that the velocity is ds by dt, and this is equal to 300, and from this equation we can write that ds is equal to 300 times dt. So now we have to integrate this from t equals to 0 until t, and when t equals to 0, s is equal to 0. So we have to integrate this from 0 to s. Now again if I integrate this, this will cancel out. So we will have s from 0 to s, and the integration of this will be 300. 300 is constant, and the integration of dt is t. So this will be 300t from 0 to t. So now if we put these boundary conditions, we will have s minus 0 equals to 300t. So we can say that s is equal to 300t. And now if I put the t equals to 10 at t equals to 10 seconds, s is equal to 300 into 10. We need to put t equals to 10 in this equation. So this is equal to 3000 feet. So in 10 seconds the jet plane travels 3000 feet, right? So somewhere here is that 10 seconds. Let me write this is 10 and this is 10. So let's say now one box represent this this is 3000, this is 1000, 2000, 3000. So somewhere here is 3000, and this represents this 300t, this is s is equal to 300t. So this is the we can compare this with y equals to mx plus b. So when t equals to 0, when t equals to 0, s is 0, and when t equals to 10 seconds, the s is 3000 feet. So from this we can conclude that this is a straight line, so we need to join these 2 points like this. So from 0 to 10 seconds, the s of t graph will look like this, and this is represented by 300t. Now for the second interval, that is when t is greater than equal to 10 seconds and less than equal to 20 seconds. So this is the second interval, and in the second interval the acceleration is, the jet plane is actually deaccelerating. So the deacceleration is the straight line. The deacceleration is following the straight line. So we need to have the equation of the straight line. So now for this, let's consider some point here, and let's say that the coordinates of, let's consider a point somewhere here, let's say, and let's say that this point is, let's say somewhere here is t. So this is t and acceleration, this is acceleration somewhere, and the coordinates of this point is t equals to 20, and this is acceleration is minus 10. So now we need to apply the slope, right? So the slope is m, which is equal to change in y divided by change in x. So now the change in y is, this is the change in y. So the change in y will be minus 10 minus a. So let me write minus 10 minus a divided by the change in x. So the change in x will be 20 minus t. This is divided by 20 minus t. Similarly, if we consider the coordinates of this point, so the coordinates of this point is 10 and minus 20. So now the slope can also be determined using these 2 points, right? We have used these 2 points, and then now we need to use these 2 points, right? So this slope will be equal to again change in y. So now change in y will be minus 10 minus 20. So this will be minus 10 minus 20, and then change in x will be 20 minus 10. So that is 20 minus 10. And remember that while using this method, you need to consider the same order, right? We have subtracted, the change in y is minus 10 minus a, and similarly for this is minus 10 minus 20, remember, right? So we have to follow this order. So now from this, if we simplify this equation, this will be minus 10 minus a divided by 20 minus t equals to minus 10 plus 20 divided by 10. So this gives us 10 divided by 10, so this is 1, right? So this means that this is equal to 1. And now if I cross multiply both sides with 20 minus t, so we will have 10 minus a equals to 1 multiplied by 20 minus t. This is minus 10 minus a 20 minus t. And now if I bring this minus 10 to the other side, so it will become plus 10. So this is minus a, let me write minus t first, and this is 20 plus 10, this is plus 30. And now if I multiply both sides with minus sign, so this will become plus, and that is minus 30. This is minus 30. So now this is the equation of this line, which is represented the deceleration, and this is plus t minus 30. Now we can verify this equation if you people want to find that whether we have determined this straight line equation is accurate or not, right? So if I put t equals to 20, if I put t equals to 20, it need to give me the acceleration equal to minus 10. So let's put t equals to 20. So acceleration, this is 20 minus 30, so this gives us minus 10, right? So this is the equation of that acceleration between 10 seconds to 20 seconds. Now we know the acceleration as a function of time between this interval, and we have to find the velocity as a function of time. So now we know that acceleration is dv by dt, and now from this we can write that dv is equal to t minus 30 into dt, and to find v as a function of time we have to integrate this. And now the integration is from 10 to t, since we are considering this interval, and this interval starts with 10 seconds. So this is from 10 to t, and the velocity at t equals to 10 seconds is 300, right? As we know that the velocity is constant, so the velocity at 10 seconds is 300. So now this integration will be from 300 to v. So now again, if we integrate this will cancel out, so this will be v from 300 to v, and then the integration of this will be t square divided by 2 minus 30t, and this will be from 10 to t. So now if we put these limits, this will be v minus 300 equals to 1 divided by 2 t square is 0.5 t square minus 30t, and then we have to put that 10, so this is minus, and 1 divided by 2t square, so that is 0.5 into 10 square minus 30 into 10. So let's find this constant. This is 0.5 into 10 square minus 30 into 10. This gives us minus 250. So this is v minus 300 equals to 0.5 t square minus 30t minus, this gives us minus, and minus into minus is plus. So this is actually minus into minus 250, so this will give us plus 250. So this is plus 250, and on the other side of equation, this minus 300 will become plus 300. So now 250 plus 300, 250 plus 300 gives us 550. So this is 550, and we are left with v, right? So this is the velocity equation for t equals to 10 seconds until 20 seconds. Now this is a quadratic equation, and this is 0.5 t square. Now let's find the velocity when t equals to 20 seconds, right? So since this interval ends at 20 seconds, we have to find the velocity at t equals to 20 seconds. So that will be 0.5 into 20 square minus 30 into 20 plus 550. So let's find this. This is 0.5 into 20 square minus 30 into 20 and plus 550. So this is 150. So the velocity at 20 seconds is 150. So now let's find this point out, so this is here, somewhere here is that 20 seconds, and 150 is somewhere here, since this one unit is 50, so this is 150. So this is that point somewhere, and now as we can see that the v as a function of time, this is a quadratic equation, and the coefficient of the t square in a quadratic equation is positive. If this is positive, then this will be a second degree curve. From 10 to 20 seconds, we will have a second degree curve, and it will be, the curvature is going to curve in the upward direction, right? We will have the concavity like this, right? So let's draw that. So this will be the v of t from 10 to 30 seconds. This is the proximate curve, right? And this is represented by 0.5 t square. This is 0.5 t square minus 30t plus 550. Similarly, to find s of t, we need to write this is ds by dt. So this is also equal to ds by dt, and if we multiply both sides of equation by dt, so we will have ds equals to 0.5 t square minus 30t plus 550 into dt. And again we need to integrate this. Now we need to integrate this from 10 to t, and similarly when t equals to 10 seconds, this is when t is equal to 10 seconds, s is equal to 3000 feet, right? So we need to integrate this from 3000 to s. Now if we integrate this, again this d will cancel out and we will be left with s from 3000 to s, and the integration of the right hand side, this will be 0.5 t to the power 3 divided by 3 minus 30t square divided by 2 plus 550t, and the limits are from 10 to t, and 0.5 divided by 3 is 0.167, or we can say that this is 1 divided by 6. Let me write it is 0.167 t cubed. Now let's put all these limits. This is s minus 3000, this is 0.167 t to the power 3. 30 divided by 2 is 15 plus 550t, and now let's put the lower limit, that is 10, so minus 0.167 into 10 to the power 3 minus 15 into 10 square and plus 550 into 10. And similarly, if I bring this minus 3000 to the other side of equation, so it will add up to this constant, so that will become plus 3000. So this is minus this minus into this, so minus into 0.167 into 10 to the power 3 minus 15 into 10 square plus 550 into 10 and plus that 3000. So we will get this minus 1167. So s of t, this s as a function of time is equal to 0.167 t to the power 3 minus 15t square plus 550t and minus 1167. We get 1167. So this is s as a function of time for the interval t equals to 10 and 20 seconds. Now this is a third degree curve, so we need to plot it, right? Its curvature is going to point out in the downward direction, so we will have the graph somewhat like this, and we want to find the s at t equals to 20 seconds. So that will be 0.167 into 20 to the power 3 minus 15 into 20 square plus 550 into 20 and minus 1167. So this is 5169 feet. So when t equals to 20, it is 5169. So this is 3000. So this is 4000, 5000. So let's say that somewhere here is 5169. So the graph will look like this, and this value is 5169. This is 5169. Now the third interval is from t equals to 20. Let me copy this. Now the third interval is from t greater than equal to 20 second and less than equal to t dash. Now t dash is unknown, but from the graph we know that acceleration remains constant for this interval, and that is equal to minus 10. So let's write that the acceleration, which is equal to dv by dt, equals to minus 10, and from this we can write that dv is equal to minus 10 times dt. And now we need to integrate both sides of the equation. Minus 10 is constant. Now we need to integrate this from 20 to t, and this will be from when t equals to 20 second, velocity is 150. This is 150 feet per second. So this is from 150 to v. Again, when we integrate this will cancel out. We will have v minus 150. If I put all those limits, this is, and this integration will be minus 10t, and this will be from 20 to t. So now let's put those limits. This will be v minus 150 minus 10t, and then minus 10 into 20. So this is minus 10t, and this will become plus 10 into 20 is 200, and this 150 on the other side will become plus. So this is minus 10t plus 350. So now the velocity for this particular interval is the straight line, which has a slope of minus 10, and the y-intercept equals to 350. So now it is said that find t dash when the jet stops, right? So we determine the time t dash when the jet plane stops. So this means that when v equals to 0, t is equal to t dash. So now let's put in this equation. So we will have 0 minus 10t dash plus 350. So from this we can have t dash minus 10t dash equals to minus 350, and from this we can say that t dash is, minus will cancel out, and this is 350 divided by 10, or we can say that this is 35 seconds. So the jet will come to rest in 35 seconds. So this is that t dash which was required, and at t equals to 35 seconds the velocity is equal to 0. So now if you want to plot the velocity, so if this is 10, this is 20, so 30 is somewhere here, and this is 35, right? So this is somewhere here is 35 seconds, and from t equals to 20 until 35 seconds the velocity is following the linear straight line. So this is v of t, and this is represented by minus 30t plus 350. So this is v of t graph, and similarly now we have to find s of t equation. So now we have the velocity. This is the velocity equation. So now we can write that the velocity, which is equal to ds by dt, is equal to minus 10t plus 350, and from this we can write that ds is minus 10t plus 350 into dt. Again we have to integrate this, and this integration will be from 20 to t, and when t equals to 20, s is equal to 5169. So this is from 5169 to s. So now if we integrate this will cancel out. Again we will have 1s, and this is 5169 until s, and the integration of this will be minus 10t square divided by 2 plus 350t from 20 to t. So this will be minus 5169, minus 10 divided by 2 is minus 5t square plus 350t, and if we put the lower limits, that is minus 5 into 10 square plus 350 into 20, and if I bring this to the other side of equation, so this constant will aid to this constant. So this is also 20, right? This is 20. So this is minus into minus 5 into 20 square plus 350 into 20, and that plus this 5169 will become positive, so that is plus 5169. This gives us plus 169. So this is S minus 5t square plus 350t plus 169, and this is S of t equation. This is in feet. And again, as we can see that this is a quadratic equation, this is a second degree curve, and the coefficient of t square is minus, so we can approximately draw this curve for this particular interval. But before that, first find the s value at t dash, and t dash is 35 seconds. So now put t equals to 35 in this equation. So this is minus 5 into 35 square plus 350 into 35 plus 169. So this gives us 6294. So this is 6294 feet. So now here we have 6294. So this is somewhere here is 6000. So 6294 will be, let's say if this is 35, so let's say somewhere here is 62, that is 6294. So somewhere here is 6294, and the graph is, the curvature of the graph is going to point out in the downward direction. So we will continue this. So now this is the solution of this particular problem. T dash is equal to 35 seconds. The jet comes to rest in 35 seconds. The velocity becomes equals to 0 after t equals to 35 seconds, and this is v of t graph, and this is s of t graph.